everybody, I'm Nick, and in this video I'm so excited because we have .NET 11 Preview 1 out, which brings the biggest runtime change in .NET since forever. Await Async was added all the way back in C#5, and it changed the way we write code fundamentally. If you wanted to write asynchronous code that looks synchronous, well, you couldn't really do it, you had to hack your way around. But Microsoft changed the game when it introduced Await Async. Now you see it everywhere, and the concept existed, but it was way clunkier to write. Now it's basically viral, it's everywhere. There's no code that doesn't use Await Async in some capacity. But the way it was implemented back in the day was interesting because Microsoft is very scared of touching the runtime, especially in the .NET framework days, because they're basically too scared of breaking it because it ships with Windows, or it used to ship with Windows in a certain way. But now with .NET Core and .NET in general, and the way new .NET versions are shipped, we can have things like this, and we've seen other features that change the runtime, but not as much, I don't think. And basically, by just enabling the new way of doing Await Async, your code will become easier to debug, you will know what's happening just immediately, and more performant. You have to do very little to gain all of this performance, and of course we don't know how it's going to look in the release, but what I have today is, yeah, it was shipped in Preview 1, I have Preview 3 here, which actually improves a few things from what I can see, and I'm going to go straight into it because it is just so cool. So what I have here is a console application, which is just a .NET 10 application. So nothing sort of fancy here. Ignore the rest things, preview features and stuff. Like, we're going to talk about these in a second. But this is just a .NET 10 project. And I'm going to go here very quickly and say task.delay. I'm going to add an async functionality, right? We're going to run this code. It's going to wait for a second, and then it's going to print the time. So if I was to just quickly run this just to see how it works, pretty straightforward, runs, and after a second, runs again, tells us the time. That is it. Now, this is running, as you can see over here, in release mode. Await Async, the code that is produced, is actually different in debug and release. If we just change this to debug and we build the project again and we take a look at the lowered code, basically the code that will be compiled from high-level C# to low-level C#, you will see a lot. You will see a state machine over here, you will see some debug step through, you will see the state machine itself being built in here. As you can see, we have these things, we have some states, we have the actual code here of console write and then the await, but then you get an awaiter, you check if it's completed. If not, it's a pretty complicated thing with this move next. It's a true state machine. If you've ever seen a state machine ever, that's fundamentally how Await Async works. And as you can see here in debug mode, the state machine itself is actually a class. Now, classes allocate, and the reason why it's a class is to make debuggability locally easier. But if you actually change this to release mode, you will see that this will now turn into a struct to try to save some memory, because it is a lot of code, right? A lot of things are happening, and the more complicated you make the code, the more state machine code needs to be written. The reason why it was made like this, like I said before, was we don't want to touch the runtime, so we will basically make all of this Await Async functionality as a lowering feature. So C# will write C#, which will then be compiled into IL code that looks like this, which again, it's a lot for 3 lines of code, many instructions, but it was needed so we don't touch the runtime, because touching the runtime is dangerous. Now, in .NET 11, this all goes away. We will not have a state machine in the IL code anymore. There will still be things on the runtime, but there will be runtime exclusive things. So, if I just go here in the project and I say turn this into .NET 11 and I build the project, I just do that, no other change, then as you're going to see over here, well, the compiler or the IL helper will not be able to decompile this code or lower this code actually because the feature hasn't been implemented yet in the IL viewer of Rider. That's fine, but we can actually, if we go over here in the IL, you will see immediately it's way less code. immediately way less code. And I can talk you through what's happening here. Here we have the 1000, which is the delay that we have over here. You still have the write lines, and then all of that state machine becomes this call over here, the task.delay, the actual call to the task class, and then the actual awaiting becomes this method, this await method that takes this task that needs to be awaited. And we have this await method. Now, if you don't know what this looks like, I can actually very quickly show you. Basically, signature-wise, Microsoft added this async helpers class, which now has all of these methods, which have these method implementation options as async, which makes this like a runtime implemented method. And this is what the compiler will use when the code is basically compiled, and then the runtime will take over and do the rest of the work. This is public, so you could, in theory, just say, I want to import this and call these methods. Like, nothing is really stopping you from looking into them. They are public. I don't know if they're going to stay public. They probably will stay public. But as you can see, a lot of stuff are happening here. And please be my guest and go and take a look at those. But that's what will replace basically the state machine from compile time to runtime. But how will all this perform, and what's the benefit of doing it? Well, first, I'm going to show you some benchmarks. So I'll go ahead and just comment this out, and I've made a few benchmarks over here. So I'm going to actually swap a few things around so I can run my benchmarks, because this is that early that benchmark.net doesn't have .NET 11 support as a runtime, so I had to program it in. But basically, to enable this feature, all you need to do is target .NET 11 and then enable preview features, and then also say that you want to enable the runtime async as on. By default, it's off. But if you enable it as on, because it's, again, early days, bugs might happen. By the time of the release, there shouldn't be any. But you have to explicitly opt into that feature. And with that now in place, I can go here and I can say benchmark runner dot run, and I'm going to run my async benchmark. If we want to take a look in there just to see what's in here. Basically, I'm configuring sort of the job we're going to run, and then the code itself is very basic. We have a random with a deterministic random number as a seed. Then 10,000 integers go into a list. I'm using an integer because I want to show you the simplest sort of data type. I don't want to go with a string that will allocate strings and stuff like that. We want to see what's the actual performance overhead of the feature. And then I'm using a static async task that returns an integer, and it is not a true async await task. We're returning it from result, which basically isolates the functionality so we can just test how the thing itself actually works. Now that's just 10,000 items. Now, all I'm going to do is I'm going to go to the console and I'm going to say, run this for .NET 10. So if I just go here, this will now start running. While this is running, I want to announce something that's very exciting. First, if you haven't seen on Dome Train, we have a massive C# course, free to keep forever. If you want to learn C# or learn the latest feature of C#, you can use that link in the description and enroll. But we also now have a data structures and algorithm course in .NET that is free to enroll for 14 days, a TypeScript, a JavaScript, and a Python course, as well as the Postgres course. Links below. You can learn in an interactive way and actually write the code to pass those tests, the exercise we're going to set for you. So very excited for those things we're launching. Check them out. And now let's take a look at what we have. So we have 174.9 microseconds and 1.41 megabytes of memory. So it runs pretty fast, right? If we just quickly take this, just to remember where we are, I'm going to just put it here. Not the best place to put it, but I'm just going to put it here for now. And then all I'm going to do is I'm going to say, okay, now run this for .NET 11. And let's see how the two compare. So let's wait for it to run. Results are back. And as you can see, it is around 40 microseconds faster. Again, in the microsecond world, it's not the most exciting thing, but the bigger your code, the more important and the more complicated the state machine, the bigger the difference should be. And also the memory allocated is half. Now, in Preview 1, it seemed like it used to allocate more memory. Now it seems to be allocated in Preview 3 less memory, so there might be some optimization going here. I don't know how it's going to be on release, but it's faster, more memory efficient, you didn't really need to do anything. I don't know if it's going to be like this in every single scenario, especially the memory thing, but so cool. And like I said, the code itself looks nothing like it used to. If we take a look at the IL viewer here, this in the .NET 10 version, oh, and actually we can see a few things here. Yeah, here we go. So async helpers, await, task from result. Just for argument's sake, I'm going to switch this just for argument's sake to .NET 10, just to show you what this code would look like. So .NET 10 here, let's just quickly build that, and then as you can see, what the hell? Look at this. Look at this. It goes from a bunch of crazy state machine states to basically just a line of code calling the async helper. It is so cool, and we didn't really need to do anything. And the best thing about this is when things fail, if you've seen any async exception ever, you would know that it's a pretty stack trace, no pun intended, with a lot of stuff and hard to trace what actually happened. With this version, you will actually get pinpointed to exactly what happened without this chunky stack trace. So not only do you get the best performance and memory allocation, at least in this example, you also get a cleaner stack trace that tells you exactly what happened. It's amazing. I love it. I'm glad we're adding this. It should lead to a smaller footprint as well with the build of whatever project we're building. Maybe runtime memory will be more chunky, but I haven't really validated that, so we have to wait and see when .NET 11 is out or latest preview is out. But for what I can see right now, that's nuts. And I'm so happy Microsoft has added this. Is it a feature like discriminated unions that you can just go ahead and, put in your code and be excited about? No, but the fact that we're working on such a fundamental feature, this has the potential to speed up a lot of .NET code, and I can't wait for Stephen Tobe's performance blog this year. But now I want to know from you, what do you think about this, and do you have any suggestions on similar await async features that could be improved? Leave a comment down below, let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.